In section 9.5, we're going to work on learning how to solve equations by completing the square. And our key vocabulary here is what is completing the square and what is a perfect square trinomial. And what that is we've already talked about the idea of the perfect square of a binomial. We know that a plus b squared is equal to a squared plus 2ab plus b squared. And what we're looking at here is, how do I create the square of a binomial? Because it will allow me to go on and solve a quadratic function by taking the square root of either side. So that inherently is what we're doing, is we're going to create a perfect square trinomial through a process that's called completing the square. So this again is a re-explanation of what I was talking about, is when we have x squared plus bx, if I find the correct constant to add, I can complete the perfect square trinomial. And so the process of completing the square is finding this correct constant to add. An essential element that you have to remember, however, is that the leading coefficient has to be 1. Right? We can't have a leading coefficient that is different if we're going to work on completing the square by using this rule. Okay, so if I wanted to look at this, I would want to take the b value. Right? So what it says is that for this value b, I'm going to want to do, and in this case that's 5, what I'm going to want to do is take b, divide it by 2, and square it. So that's what I'm going to do. I'm going to take 5, divide it by 2, and square it. And that will give me 25/4. So to make the perfect square trinomial here, I'll have x squared plus 5x plus 25/4. And what this is going to factor down to be is going to be x plus 5/2 squared. And what it always is it's going to be this item, and this item become here, here, and here. Okay, so let's take a look at another example of that and how it might work in a regular quadratic function. Okay, so here's a quadratic function I want to solve. This might have started out as a problem like this: c squared minus 14c, minus 15 is equal to 0. It might have started out that way, and if I add 15 to each side of the equation, I'll get this. And then I need to find this correct value, so I'll have c squared minus 14c plus something that we don't know will be equal to 15 plus that same something. Whatever I add on this side, I have to add on that side. And the way I'm going to find that is I'm going to take 14 divided by 2 and I'm going to square it. So that's going to be 7 squared, or 49. So over here I'm going to write 49. Over here I'm going to write 7 squared. They're the same value. And I'm doing that because I don't want to lose track of what is my binomial going to consist of. Well, it's going to consist of the c, the minus sign, and this value that's being squared. Okay, so it's going to be c minus 7 squared. And then that's going to equal 15 plus 49, so that's going to be 64. Okay, and the point of doing this is now I want to take the square root of either side, so I'll get c minus 7 over here will be equal to plus and minus the square root of 64. I introduced the radical, so I have to also introduce plus and minus. And then what I want to do is I want to go ahead and finish this out by adding 7 to either side. So I'll have 7 plus or minus the square root of 64, which is 8. Right? So if I have 7 plus 8, that's 15, and 7 minus 8 is -1. And these are my solutions. Okay, so let's look at what this would look like when we don't have a leading coefficient of 1. I need to have a leading coefficient of 1. Here I had it. In this example, I don't have it. So the first thing I'm going to want to do is I'm going to want to move the 20 to the other side. And then I'm going to want to factor a 3 out of each of these two values here. So if I factor a 3 out, I'll get w squared minus 6w equals 20. And now I know that I'm going to take this 3 and the w squared minus 6w plus some value, and it'll be 20 plus some value. So to find that value, I take 6, I divide it by 2, and I square it. Right? And that's going to equal, I want to make sure I get this out of the way, leave a little extra room. So 6 divided by 2 is 3 squared, so that's going to be 9. So over here I'm going to put 3 squared, which is 9. But when I go to put the 9 over here, notice that this is being multiplied by 3. So I didn't put in 9 to this side of the equation. I put 9 times 3. So that's going to be 27, and you have to account for that. Okay, if I continue on with my problem, I'll have, this is going to be w minus 3 squared on this side, and this over here will be 47. Okay, now if I want to solve, I'm going to divide both sides by 3, and then I'll get w minus 3 squared is equal to 47 divided by 3, so I'm going to do 47 thirds. Okay, if I check really quick, I know that 3 goes into 4, leaves 1. 3 is not going to go evenly into 17, so I'm leaving it as that. And if I go through here now and take the square root of either side, I'll get w minus 3 is equal to plus or minus the square root of 47 over 3. And then I'm going to add 3 to either side. So I'll have 3 plus or minus root 47 over root 3, and that's a problem. I can't have that. So I have to rationalize this denominator, and I do that by multiplying it by itself. So radical 3 is an irrational number. I'm not allowed to have it in the denominator of a fraction. So 3 times 47 is going to be 120 plus 21. So that's going to be 141. Root 141 over 3. And these are my two solutions. Okay, so it's a little more complicated when you don't start with a leading coefficient that is not 1. You just have to factor that value out before you continue on. And you also have to remember that when you add here into the parentheses to create the square, whatever you're multiplying this by, that will be distributed into this, and you have to account for that when you add it in on the other side. Okay, let's look at this in some form of application. So we're going to paint a chalkboard on this door, but we want to leave, we don't want to do the whole door, we're going to leave a border all the way around the chalkboard paint that we're going to paint here in the middle. And I have enough chalkboard paint to cover 6 square feet, so I have to find the width of the border to the nearest inch. So my x value is here. When we look at, I have a dimensions of the door is 7 by 3. If we look at a verbal model, I know that the height of the door minus the border times the width of the door minus the border is going to equal the area. So that's my verbal model, is basically width times height equals area. And when we start looking at that, when we look at the height is going to be 7 minus 2x, and the width is going to be 3 minus 2x. and those are going to equal the area, and the area I've got is 6 square feet. Okay, so that allows us to start working with this problem. If I want to solve the equation, the first thing I need to do is I need to multiply this all out. Right, so I'm going to have 21, and then I'm going to have minus 6x minus 14x plus 4x squared. And it would make sense now, I'm going to put this in the correct order. And I'm also going to move the 21 to the other side. Okay, so I'm going to subtract 21 from either side of the equation. So I'll have 4x squared minus 20x is going to be equal to 6 minus 21, so that's going to be negative 15. And now we want to go ahead and I need to get a leading coefficient of 1, so I'm going to factor a 4 out of this. So I have x squared minus 5x. And I know I need to add something to it. And that's going to equal negative 15. And if I go through, I want to take 5 divided by 2 and square it. So I'm going to take 5 divided by 2, and I'm going to square it. So I'm going to put 5 halves squared in here. And over here, that's 25 fourths. And it's going to be multiplied by 4, so that's just going to be 25. Okay, so over here, I'm going to get 10. And over here, I'm going to get 4 times x minus 5 halves squared. Now I'm going to divide both sides of my equation by 4, so I'll have x minus 5 halves squared is equal to 10 divided by 4, which is 5 halves. And then I want to take the square root of either side. So actually, because I'm going to take the square root of either side, I'm not going to bother simplifying this fraction. Why, you may ask? And that's a good question. I'm not going to simplify this to 5 halves because 4 is already a perfect square. So when I take the square root of either side, I'll get x minus 5 halves is equal to the square root of 10 over the square root of 4, which is 2. And to finish my problem, I'll have x will be equal to 5 halves plus or minus. By the way, I didn't put the plus or minus in here. Root 10 over 2. And this is going to give me decimals, but that'll tell me the size of this little border right here. To determine the width of the border, I'm going to need to pull out a calculator and figure out what this root 10 over 2 value is. So I take the square root of 10, and I'm going to divide it by 2. And my border then will be 5 halves pluses, so 5 is 2.5. And so we end up with 4.08 feet. Well, that's not possible, right? Because the width of my whole door isn't 4 feet. So we must have to do the minus part of that. So if I go ahead and subtract 2.5 from that and do it again, now I've got something that's more plausible. I have 0.92 feet. And that will actually be the width of my border, because it can't be both plus and minus. When I did plus, it was wider than the whole door, so that's not possible. So it's essentially 1 foot. Okay, so that's working through solving by completing the square.